So I'd like to thank John and Chuki and Dave, the organizing committee, for inviting me to speak here. And I'd like to thank all of you for being here. This is a fantastic event, my first time at 360 and Dev. And my talk title today is Framework-Free Dependency Injection. And to get this out of the way early, dependency injection is kind of a long phrase when you're building slides and have to write it all over the place. So I'm sometimes just going to write DI and know that that's the same thing. It's just way shorter and easier to fit onto a slide. A little bit about me. My name's Stuart Kent. That's my Twitter handle up there. I've been an Android developer for about 5 years now. I've dabbled in iOS and web and server-side a little bit since then, but Android is my spiritual home, and it's where I keep coming back to as a developer. So yeah, that's why I'm here today. And I work at a company called Detroit Labs. You can probably guess where we're based. We are primarily a client services company building apps on behalf of other companies that don't have the dedicated mobile resource. We do a little bit of web work as well these days, and also work on team augmentation. One of the things that we place a lot of emphasis on is apprenticeships, and as a result of that, we have a lot of juniors always coming into our company, and that has made me as a developer, as I've become more experienced, particularly sensitive to any onboarding costs that we might have in our code. So anything that juniors that are continually joining the company have to learn over and over again to work on our applications. So this is a DI talk, but I'd like to start by thinking about some trends in the Android unit testing paradigms over the last few years. So when I started building apps in 2014, everything that we had was in a fat activity or a fat fragment, and that meant all of our business logic was just mushed together with the Android framework. And if you wanted to write unit tests, well, you could kind of run things on the emulator, which was slow, or you could use Roboelectric, which is a JVM-based implementation of the Android framework. So it's like an Android device, but it runs on the JVM. But this was not ideal. It was fragile, first of all. It was essentially a reverse implementation of the Android framework APIs. And also it had feature lag. Whenever Android changed, we had to wait for Roboelectric to change and adopt the new behaviors of Android. So this was not a great time for writing unit tests. You could do it, but it was not super fun. In 2015, this was really the time when people started to think a little bit more about architecture in Android. The Android team at this point hadn't given any guidance, so it took us a little while to get here. But this was sort of the rise of MVP or MVVM as patterns that we saw being used regularly in Android. This was definitely a step up from where we were before. It meant all of our business logic was well separated from the Android framework. And we were closer to being able to write JUnit-only tests. But without dependency injection, what we're going to talk about today, it was still not really easy or possible to write these pure JUnit tests that you would ideally love to write. So in 2016, we entered this era that I kind of think of as Dagger by default. So if you're not familiar with Dagger, Dagger is a dependency injection framework. It's a framework for doing dependency injection. And around this time, it seemed to be coming up everywhere. Every podcast I listened to, every article I read, the starting assumption was, okay, so we'll use Dagger. Even if the app was a tiny little sample app, we'll pull in Dagger immediately. It's just so great. One of the things it did do is it made it really easy to get over that unit testing hurdle. Now we could control the dependencies for our consumers, and we could write tests with the whole world being very clearly controlled by us. And Dagger also has a bunch of other features that are not sort of specifically unit test related that are cool and can be used for neat applications in your apps. A downside of that, of all that extra machinery that Dagger brings, is that it's quite complex, and it is well known for having a very steep and fairly long learning curve. So if you're continually onboarding people and bringing new people up to speed on codebases, having Dagger in there is kind of a pain because everyone's paying that cost each time they join your team. And a little bit of what I saw in conversation around this time was a lack of nuance. This idea that just Dagger was the thing that you would use because everybody used it and it was a good solution. And not a lot of conversation around some of these costs. So fast forward to today, the rise of Kotlin on Android has introduced a couple of competitors to Dagger, notably Coin and Codeine. And if you are involved in the Android Twitter community, you may have seen some fairly spicy discussions going on about Dagger and Coin. And a lot of those discussions are very philosophical in nature. People care a lot about how Dagger and how Coin achieve what they achieve, not so much about how it's helping us as developers, and that to me feels a little bit problematic. So one of the things I think has been a good thing to come out of this is there have been more people stepping forward and saying, actually, I'm going to reevaluate my position based on what I need dependency injection to do for me. Maybe I don't need all of the complexity of Dagger. Maybe I just need the part that focuses on unit testing. And it's driven more interest within the community in simpler solutions. This step back that we've taken is I think, very healthy. So that's what we're going to talk about today. We're going to talk about dependency injection, but dependency injection driven by the idea that I want to be able to write unit tests. And I'm going to ignore all the other fancy stuff that I might want to do because I think unit tests are sort of the most important thing for most of us to think about. Some of the other fancy runtime features, maybe some of your apps will use those, but any application of any reasonable size should be thinking about unit testing. And I want to do this with a method that's fairly simple and not scary. And I want to have an honest discussion at the very end about the advantages of the method I've proposed, as well as the limitations that it has. What I'm not advocating for here is that we will have framework-free dependency injection for every single app. There are still going to be cases where a framework like Dagger or Coin makes a lot of sense. I just think there's a fairly large middle ground where what we're going to look at today is enough and doesn't incur all of the costs of those frameworks. So here are the takeaways I'm aiming for. I want you to leave thinking that manual dependency injection is viable in certain circumstances. And I want you to see a practical recipe applied to Android so that if you are new to dependency injection, you have a way to get started with the concepts that doesn't involve having to learn this giant framework first. And especially if you're a little bit more experienced, I want to use this as an opportunity to remind you to always be looking at your tools from this point of view. This point of view that just because everyone else is using a thing doesn't mean it's ideal for you. You should always be thinking about what are the pluses and the minuses of the decisions that I'm making in my technical stack. So let's start by thinking about just a simple Kotlin example first. No Android at this stage. And I'm going to start by looking at this little class I made called Human Time Helper. And the objective of this class is to give you a human readable time of day. So it will, that is the only functionality that this class offers. It will give us a string when we call this get time of day method. And the way it works is it will say, okay, figure out what the local time is right now, figure out what the hour is, and then based on the hour, tell me if it's morning, evening, afternoon, or night, but not in that order. So does anyone here feel confident they could write a unit test for this class right now? No? Good. No one should feel confident about writing a unit test for this class. If you were to try, this is what would happen. So you would set up a test and you would say, here's a new human time helper, and let's say I want to test the morning case. So that's my expected result is the string morning. And then I'm going to call human time helper.getTimeOfDay, and then I'm going to say, well, that result I want to be equal to morning. But this is only going to pass if this test gets run while it's morning. If it's afternoon, this test is going to fail. And that doesn't even have to mean it's afternoon where you are. It could be afternoon where you are, but morning wherever your CI server is. So this is what we would call an extremely flaky test. This should not give us a lot of confidence in our code. If we're running tests like this and saying, well, 30% of the time it's passing, that's good enough. That's not really what we're aiming for with unit testing. So what is the point of writing unit tests like this? Not really a lot. So this is the problem line right here. This is where we are what is called tightly coupling our consumer, this human time helper, to the local time.now dependency. We have no ability to use the human time helper without also using local time.now. We cannot separate those two. So these are the goals. If I was to look at this and say, what are the goals? What do I want to be able to do in this situation? Well, I want to be able to write a unit test that actually means something. And so to break that down one level further, I would say, I want some way to specify a fake time in unit tests so that I can control it. And then I want to continue to use the real time in production. Like I don't want the production behavior to change at all. I just want to be able to have a bit more control when I'm testing. And that's in general the theme that we're going to be taking throughout this talk, this unit test-driven dependency injection is I'm always going to be looking to be able to put a fake X in place of a real X whenever I'm writing unit tests. So let's walk through a recipe for doing this. So step one is going to be to define an interface that describes the ideal behavior of our dependency from the point of view of whoever's using it. So in this particular case, what did I care about when I was writing that code? I needed to know the current hour. I didn't need to know the current minute or second or millisecond. All I needed to know was the current hour. So I'm going to define an interface here I'm using the I prefix just so it's easier for you to tell during this talk what's an interface, but that's not a naming convention that you need to adhere to. But all this interface does is says, I need something that can tell me the current hour. Step 2 is going to be to go back to our original human time helper class and inject an instance of that new interface into the constructor and save it as a property within that class. And thanks to Kotlin, this is a little bit shorter. If this was Java, we'd need to have a separate constructor and a separate field. This nice private val syntax allows us to do both of these things at once with Kotlin. And then step 3 is going to be to go through my code, and wherever I was using the old dependency, which in this case was localtime.now, I'm going to replace it with a usage of whatever interface gets given to me in my constructor. So here, we've replaced that line with just clock.hour. So we've already done most of the work to call ourselves dependency injectors. Someone else is giving us a clock, and we are using that clock. We're no longer going and fetching our own clock. That's the important part of dependency injection. So there's a few more steps just to clean up here. One is to make sure that we have that production implementation of our interface that works exactly as the old version used to. So here I've called this system clock, and the implementation here of this interface is to say, call localtime.now.hour, which was exactly what we did before. So you will almost always see that your production implementation is take the old implementation and just put it in an interface method. So that's the only change right here. And then we use, wherever we were previously constructing a human time helper in our production code, before we would have been able to construct it with no constructor arguments, we've added a new parameter to our constructor, so now whenever I use a human time helper, I have to give it some clock, and the clock I want to give it in production is a system clock. So we'd update that everywhere throughout our production code. But this is where it gets really exciting, because now when I come back to my test, I have the ability to give it a different kind of clock. And what I want is a clock which has extremely repeatable behavior. So the important lines to look at here are these three. We're still checking the morning case here, but when I'm constructing my human time helper, I'm giving it a clock that I'm making on the fly. Right now I'm just using like an anonymous class to do this. But what I do is I override the iClock interface and I say the hour is always going to be 6 as far as this clock is concerned. That's as predictable as things can get. This clock, I know exactly what time it is all of the time. And so this test should pass 100% of the time. It is now useful as opposed to useless. And just to prove that out, if you were to write a second test, you could change the hour to 19 and expect that you would always receive evening as the output from this class. So I've taken back the control that I need to write these repeatable unit tests. So let's just recap the recipe that we went through. And what we're going to do next is apply it to a couple of Android examples and a couple of realistic Android examples, because I don't want to present you with this idealized recipe and then not show you some ways in which it has dependent flex in real life. So the recipe that we went through was we created the ideal interface. We injected that interface into the constructor. Then we used it everywhere in our production implementation. We created a real implementation that we could give to that consumer when it needed one. We passed that real implementation everywhere in production. And then finally, we were able to create a mock implementation, a fake and predictable implementation for use in tests. 6 steps, not too bad. A lot easier than getting Dagger up and running. So one question I often hear is, how do I know which dependencies I need to inject? And the rule of thumb I'm going to give you here is the reason that we had such trouble trying to think about writing the unit test for that original example is because its behavior changed over time. And so the dependencies that you want to focus on injecting using a recipe like this are those that are volatile in some way. So they change with respect to time or with respect to network state or local disk state. That's what you're looking for when you're trying to figure out what do I actually need to be able to replace. Anything where you need to turn inconsistent behavior into consistent behavior for testing. So let's jump over to Android, and I'm going to start out by taking a look at an Android MVP example, which is probably slightly surprising because MVVM has sort of taken a little bit more of a leading role in Android. The reason I'm going to start with MVP is just that it's slightly simpler. So we'll go through this and we'll show the differences necessary for MVVM. So we've dealt with this dependency which is affected by time, I'm going to introduce two other very common dependency variabilities that you'll probably be used to seeing in your apps. One is network conditions, anything that might depend on the internet state, and local storage state, anything that might depend on what's on the disk of the device at any given time. And I always find it helpful to think about an actual example. So this is a little toy example I put together. This is a screen in an application that makes a network request to fetch some users' credit cards. And if they've used the card before, whenever they select a card, we'll just mark that one as a favorite locally. And then the next time they come back to the screen, they'll see like a pink star to tell them, hey, this is the one you used before. This is your favorite. And if any of these card numbers match your credit card, just be assured I didn't steal anybody's wallet for this. This is pure coincidence. So this is the code that powers that screen. And it's not perfect code. There are issues with this code apart from the dependency injection side, which is meant to reflect reality. So we have a constructor that takes a view, which is necessary for the MVP pattern, and it also takes a context, which is slightly strange. And that context is there because it's used to create the shared preferences in this class that are going to be used to save that ID, the ID of the last used credit card. So the first thing that happens is we call this refresh cards method. That figures out if we have a last card ID, and then it fetches all the cards from the network, figures out if one is the favorite and puts the star on it, and then sends that off to the view to be displayed. And then when a user interacts with these credit cards, a credit card is given to us as selected, we put that into our shared preferences, and then we advance somewhere in the application. So that's all of the code for this screen. The way we'd use this presenter is typically in an activity or a fragment, we would have a presenter field, late init var here because we don't initialize it until onCreate. And then in onCreate, we just call the constructor and we'd give it this, the view, and this, the context. And that would be enough to be up and running with this MVP example. So the first dependency I want to think about injecting rather than hard coding here is this REST API. This is what we use to fetch the user's credit cards. This is going to be problematic if we're writing tests if the network is down or if there is some state which maybe you're hitting a different user. You're going to require authentication to be in place before you can fetch someone's credit cards. Again, very difficult to write a good test around this, a good reliable test. So let's go through our recipe again. First of all, we're going to create the ideal interface. And as far as this consumer is concerned, our ideal interface is just something that can give you back a list of credit cards wrapped in an observable. So I pick on a name, which is kind of descriptive here, and that's the only method that we need in this particular interface. We're going to inject an instance of that into the constructor by adding a new constructor parameter. And then we're going to use it in our class, and that just means we take out the old one and we put the new one in, and everything else remains the same. This is the only line that's new here. So this is one deviation from what we saw in the first example. The REST API is probably a class that we wrote. Like we probably wrote our own REST API class, and that's what we were using originally. So when we're doing something like creating an idealized interface, we might not need to create a brand new production implementation. We might be able to go to our existing implementation and just add an override keyword here to make it conform to that interface. So we might not need a whole new class. This might just be an update rather than a creation. And this works if you pick the method name in your interface to match whatever method name you've chosen in your original REST API class. So in production now, when we create the presenter, we have to make sure that we give it the real REST API so that in production we still make real network calls and get credit cards back. And this is the step 6, where we would say, okay, now I can pass mock implementations in tests and I can do testing. We have to be a little bit careful here. We can't do this yet because of the other dependency that we haven't dealt with yet. So this is a little bit all or nothing. If you're thinking about refactoring a single presenter to use dependency injection for testing, you might have to do several dependencies before you can start writing any tests. So let's do that. Let's figure out what we need to do with our second dependency. So this one's slightly strange in that this is where we're passing in a context and then using that to create shared preferences. And then the shared preferences are what we interact with to save and load the last used card ID. Now, if we could, in theory, because we're already passing in a context, we're kind of injecting a context here. But if you think about what we'd have to do with this in a unit test, that means we'd have to mock a context, and then we'd have to make sure that when we called get shared preferences on that context, it returned a mock shared preferences. And the shared preferences API is huge. Shared preferences is an interface, but it's a huge and very generic interface. So we can do better than this. We can do better than just saying, I'll just mock the context and live with it. And the issues we have here are that disk storage is stateful. So if I'm running this on a device, maybe a previous test has changed some state on disk. I'm expecting there to be nothing on disk for a test. Someone's already saved a previous card. Bad things happen and our test is flaky. So recipe again, let's do it. Step one is creating an ideal interface. And the ideal interface here is specifically named last card storage, and it has specifically named methods, get last card ID and save last card ID. So this is an advantage that we haven't yet seen, where we get to rename and apply some domain-specific naming to the interface that we create. No longer are we going to have to deal with prefs.edit.putThingIn.apply. Now we have a very much more descriptive API for the operations that we're hoping to execute. Much easier to read, much harder to use incorrectly. So step two, we're going to inject that into our constructor, and in this case, we have an additional step, which is strip out that context that we're no longer needing. We're going to not use the context to create shared preferences. We're going to give it a fully formed thing for saving and loading credit card IDs. So step three is to use that injected interface and remove the old shared preferences that we were keeping inside our class. So here now in the refresh cards, we can simply call lastCardStorage.getLastCardID. And when we're saving, we can call lastCardStorage.SaveLastCardID. It's much more communicative what's happening here. So in creating a real implementation, we still want to use shared preferences in our actual application. That's still the right place to store this kind of small data. So we make a new class, and we give it the context, and it becomes the thing that's responsible for managing an actual shared preferences instance. But it hides all of that shared preferences stuff away from our actual business logic. And one thing I want to call out here also is, as well as the naming convention being better here, we're also able to hide this magic constant of -1 inside this class. So when you get an int out of preferences, you have to provide a default value because integers are primitive type. That's not really a default value that we want our consumers to have to care about, so it's more communicative of us here to say, you might get an integer card ID back, or you might get null. That's a more descriptive API for the problem that we're solving. So now we can go ahead and use this real implementation in production and make a new prefs last card storage, and I give it a context, and I give that to my presenter. And now this is the biggest of all the code slides. This is not a talk on how to test, so I'm going to walk through this, but it's not crucial that you understand everything that's happening here. The important thing is that we're able to write a test that's reliable. That's the real change based on what we've done. So I can start my test by saying, okay, whenever I take this mock fetcher, I want it to return exactly these credit cards. I know exactly which credit cards are going to come back every time. And whenever I ask you what is the last card ID that got used, I always want you to say it was ID number 2. So then I take my presenter, and instead of giving it real production dependencies, I give it all these fake ones that I know how they're going to behave. And there's no variability left. And then I ask it to refresh the cards. And what I should be able to do as a result of that is very predictably say, when I fetch those cards, there should only ever be one marked as a favorite, and it should be the one that has ID 2. Repeatable, reliable, non-flaky, brilliant stuff. This particular example is using Mockito rather than the sort of on-the-fly anonymous classes that we created earlier. Swings and roundabouts, whichever mocking framework you're comfortable with is appropriate to use. So I mentioned earlier that MVVM is probably a little bit more popular now in Android because of that first-party support from Android. And this recipe that we've gone through works almost exactly the same as it does for MVP, with just a couple of tweaks. So the reason for the tweaks is that in MVVM, as given to us by Android, we're not the ones who construct view models. We don't call a constructor and give it dependencies. So we have to do a little bit more work to figure out, how do I give a production dependency or a test dependency to a view model? Construction of Android view models is actually handled by a ViewModel factory. By default, there's a default factory that makes them for us. But what we're going to need to do to inject our dependencies is make our own custom factory. So imagine we have a credit cards view model, and it has all of the same logic implemented in similar ways to what we had in the presenter. There's going to be a way to fetch cards, and there's going to be a way to indicate that a card was selected by the user. The only differences in this implementation are probably going to be that we're not going to call methods on the view to make things happen, but instead we're going to have something like live data, and we're going to push events through live data, and that's what's going to cause the view to update. But we're going to be accessing the hard-coded dependencies in exactly the same way. We're going to be reaching out to REST API. We're going to be figuring out how to take a context or a shared preferences instance. And all of that's going to prevent us in the same way from writing repeatable unit tests. So this is typically what it looks like to use a view model in an Android activity or fragment. You call this ViewModel providers class and its static method of, give it a lifecycle owner, I think. I forget exactly what the this refers to there. And then you call .get and tell it which kind of ViewModel class you're looking for. So again, not super obvious yet how we're going to take dependencies and put them into this ViewModel. So the first step is to go through all the same steps that we did before with the presenter, but with the ViewModel class itself. So we're going to, rather than have it be a 0-parameter ViewModel, we're going to say, these are the interfaces that we've defined. They represent the ideal behaviors of our dependencies. We're going to inject them through the ViewModel constructor. We're going to go through our ViewModel code and replace any hard-coded usages with the stuff that we just gave ourselves through the constructor. We're going to go ahead and create a production implementation, and we're going to go ahead and create mock implementations and tests. None of that has to change. The only thing that has to change is this new ViewModel factory. And this is going to be the thing that's responsible for making us view models when necessary. So it has to extend ViewModel provider.factory, and the method that you're required to override in here is create, which is the method that's used when someone says, please give me a view model. You can say, here is the view model that you wanted. And this is the place where we do have the ability to call the constructor of the view model. This is where we make the new view model that the factory is going to return to us in our activity. And so this is the place where we have the opportunity to inject production dependencies. Now that we're calling a constructor, this is where we can give it a real REST API in production and a real shared preferences-backed storage in production. And then the adjustment that we need to make in our activity code to actually use this custom factory is in the first highlighted line here. So before we called ViewModel providers of this, now we call this and provide a second parameter, which is our custom factory. And then it will know to use this second factory when it's asked to make a new view model. So I want to talk a little bit first about the recipe strengths. Obviously, I think there are some of these, otherwise I wouldn't be standing here giving this talk. I think this recipe is super explicit. It's very obvious what's happening at any given stage. When you look at a class or a presenter or a view model, you can see listed out in its constructor parameters all of the dependencies that it has. Very explicit. No need to go digging inside to guess. This also has a short learning curve. We've gone through this 3 times now in about 20 minutes. And it might take you a little bit longer the first couple of times. There's a little bit of an art still to identifying what dependencies you should inject and how to create that ideal interface. And there are choices there to be made as well. But it's fairly short, and it's leveraging ideas that you already know. Constructors, interfaces. Constructors and interfaces. That's basically it. There are no build or runtime performance impacts. So something that I haven't talked a lot about yet is some of the downsides of the frameworks that we have available to us. Most frameworks fall onto one or the other side of this spectrum. They either generate code, which has a build time impact, or they use reflection, which has a runtime performance impact. We might have minuscule impact because we're creating new objects slightly more frequently, nothing on the order of magnitude that a framework is gonna cause. So there's no build or runtime impact here. Consumers are also decoupled from dependency implementations. So we've created this separation specifically because we wanted to be able to provide different dependencies in production code versus test code. But I can tell you I've definitely been a part of projects where we had a production implementation of something and then a backend provider changed, and we had to have a whole new implementation of essentially the same API substituted in place all over our code. And decoupling from the implementation also makes this a lot easier. So rather than having to, for example, I don't know if anyone remembers when parse was a big thing, and parse was a backend that was used extensively and is now sort of been replaced by Firebase, but If you had parse code all over the place, you'd have to rip that out from every individual spot and then replace it with Firebase code all over your application. If you've hidden all that behind an interface, that's not so much of an issue. You can migrate partially, call by call. It's a lot less destructive to the rest of your code. And another big thing is that consumers now are ignorant of the dependency lifecycles. So in the original versions of the code, the consumer would know the difference between a new instance that it created using a constructor and a singleton that it accessed by calling a static method. And now that's not the case. Now we just give it an instance through the constructor, and it doesn't know if that instance was a new instance or a singleton. And so that frees you a little bit to actually use singletons. I know that lots of people are scared of singletons and think they're terrible ideas. When you've implemented a pattern like this, I feel like singletons are a totally reasonable thing to use. You can quote me on that. You still have to be a little bit careful. But sometimes a singleton makes sense in production code. It's just that it doesn't make sense when you're trying to write very isolated unit tests. And the other nice thing about this is that it is possible to adopt incrementally. So if you have one screen that uses a presenter, well, let's say you have all of your application using model view presenter or model view ViewModel, you can go through this process for one single screen and leave everything else alone and see how that feels. And then do a second screen and see how that feels. There's no all or nothingness here. You can do this as slowly or as quickly as you feel comfortable. Or you can try it and decide you don't like it and go back. So the other thing to be a good citizen would like to talk about is what are the potential weaknesses here? So we've taken this approach where we set ourselves a goal and figured out the simplest way to achieve that goal. But there are other goals that you might have that could be a little bit more difficult using this kind of strategy. But this first line is really important. Your needs should dictate to you whether these weaknesses are important. If you don't need any of the stuff I'm about to talk about, then you might not want to incur any of the costs of more heavyweight solutions. So frameworks like Dagger and Coin are more fully featured and will solve a lot of the issues that I'm about to bring up, but again, not for free. So let's identify these weaknesses and evaluate them and figure out how bad they really are. So one criticism that definitely gets leveled at this method of dependency injection is that you get a lot of boilerplate. So we added constructor parameters and we added new parameters that need to be read in our presenter and ViewModel classes. You cannot write this kind of pattern without adding code. So to evaluate this, I would say, yes, there's more code, but it's also explicit. There's a balance here between being really terse and being explicit, and I would personally prefer when I'm interacting with a class to know what all its dependencies are and to be able to find out where they all come from. And that's what I mean here by proximity is good also. I don't have to go searching off for some mysterious centralized dependency graph declaring code to figure out where are my dependencies even coming from. It's all right there for me. When I'm looking at a presenter class or a ViewModel class, everything I need to know is right there. I also think that this is, I think there are shades of boilerplate. I think there is some boilerplate which is terrible, and I think there is some boilerplate which is neutral. I'm not going to call it good, but neutral. An example of bad boilerplate would be something that can silently become stale. So we're Android developers, and we've probably worked with parseable. And a problem with parseable is if you change the structure of your class and you add a field, nothing tells you, hey, by the way, you're not parceling that new value that you added. So what happens is you ship your code, and then some piece of information gets lost because it gets sent through a parcel and out again, and you get some weird crashes. That's bad boilerplate. Boilerplate that can very dangerously and silently become stale. And another set of boilerplate that is definitely bad is boilerplate that's just hard to get right. Maybe there's so much of it, or it's so complex, and again, maybe parseable slightly falls into this, but equals and hash code, classic example of trying to keep equals and hash code reasonably performant and consistent is hard to get right and not mess up. In this particular case, we have compiler checking because we're using constructors. So if we miss a constructor argument, the compiler is going to tell us. We don't have to worry about any silent failures. And also, for most applications, my claim here is that most production interfaces are going to have one production implementation. So I have my REST API. I have one REST API in my app. I don't have to choose between 10. And so when I see an interface requirement in a constructor, there's normally exactly one class that satisfies it. So it's not dangerous and it's not difficult to get right if those assumptions are met. I want to be clear about that. So something else you might say is we started to define these very granular interfaces. We had like an IUser cards fetcher and an last card storage. These are very small interfaces, and so if we were to extend this across an entire code base, we might end up with hundreds of interfaces. And that adds code and that adds cognitive load. Which one of these very specific interfaces do I need to use in any given circumstance? So this is definitely a real problem. And the solution, I think, to this is to balance two different software principles against one another when thinking about how to build those interfaces. So what we've been following in this recipe is the interface segregation principle, which is to say, make very specific interfaces that only have what you need in them. But there is a somewhat competing principle that says you should value cohesion and cohesiveness in your code base. And what we've been doing is sort of the opposite of that. So what I would recommend as a mitigation to this is to think about balancing these two when you're creating your interfaces. So maybe it doesn't make sense to have an IUser cards fetcher and an IUser this, that, and 10 different IUser interfaces. Maybe it just makes sense to have an iREST API interface that you can pass into classes whenever they need to do anything RESTful. And then in testing, you only mock out the one call that you need. It's a balance, but it's a balance that can help us with this particular problem. And then this is kind of the opposite of what I talked about earlier with we have very explicit and very close proximity declarations of what our dependencies are going to be in our production implementation. But a criticism that you could level at this approach is it's definitely not dry. So every single time I am making one of these presenters or view models, I'm making a decision again about what implementation should be given to it. So that's a decision which is being made in multiple places rather than in one centralized place. So this is a problem if you need to do stuff that affects the entire application outside of production code. So an example might be if you want to write unit tests, there you probably want something that you can control across the entire application runtime and lifecycle. And this would not be great for doing that because there's no easy way to say, use this mock in all of these different places. We've built it so we can say, use this mock in this one place. And similarly, if you have the situation where there are multiple production implementations at runtime, maybe you have 2 different networking stacks or 2 different persistence mechanisms, it's going to be hard to say, I want to use this piece, this dependency for part of the app and this dependency for another part of the app, or I want to allow the user to choose which of the 2 I'm using. That's also going to be difficult here because of the distributed nature of our decisions. So this is, again, where frameworks would demonstrate some strength. Frameworks do centralize that description of your dependency relationships. That is not to say that a framework is necessary at this point. Sam Edwards, if you're familiar, works at Capital One, gave an excellent talk earlier this year, and I think gave a very similar talk yesterday, on doing dependency injection with Kotlin and solving these problems, but still not using a framework, still coming up with Kotlin-only solutions. So that's also possible and something to explore. So again, just to recap, the takeaways I want to sort of emphasize here are that manual dependency injection, as we've seen it in these recipes, is viable. It's an option that you should add into your tool belt, and you should not necessarily turn to a Dagger or a coin immediately when you're faced with this problem of wanting to write unit tests. And there's a practical recipe that I hope is described in enough detail in these slides that you can go away and practice and use if you want to in your own applications. If you are intimidated by Dagger, like I still am, start with this because it's really a good way to learn about the principles. And then as you encounter some of those challenges that we identified, that's when you can start to expand it to a more full-fledged solution. And finally, the sort of subtext of all of this is I want you to have the courage to critically evaluate tools and opinions from the community. I know Jake Wharton has done a really good job of telling everyone to be critical of Google and not to treat Google as an authority on everything. And this is perhaps an example where maybe we should not treat Jake Wharton as an authority on everything. He's right most of the time, but it's healthy to be able to have this kind of dialogue and engage in these kinds of discussions. So think about your needs and then think about your solutions, not the other way around. And thank you all for coming. Any time for questions?